Assalamualaikum warahmatullah. We are from Group 10. We will present about assignment 2, which is recyclable material classification by using convolution neural network. First, I will introduce my group members. First, my name is Nur Anatul Shakina binti Filde with metric number AE180010. Second is Nur Shakila binti Mazmin with metric number CE180047. And last is Nasuha Nurhanani binti Bacho with metric number AE180014. Okay, firstly, I will present about the introduction. Nowadays, insufficient landfills problem had increased the needs to decrease the waste and recycling them. One of the possible reasons to this is lack of effort to categorize the waste into the designated category which are plastic bottles and cans. So, the aim of this assignment is to prearrange the CNN models to train the data without overfitting and underfitting. For every process, we have to analyze the performance to detect PET bottle and aluminium detection material classification.
Hello and Assalamualaikum. My name is Nasuha Nurhanani binti Bacho and my metric number is AE180014. And today I will be explaining about the methodology used in our project. So in our project, there are three types of models that we use, which is CNN, BEJ44103, and ResNet. CNN are a class of deep neural networks that is used to classify or distinguish features from image. Okay, so here we can see the main parts of CNN architecture. Okay, from here we can see that there are two main parts, which is feature extraction and classifications. So in feature extraction, it is a convolution tool that separates and identifies the very features of the image for analysis in a process. Meanwhile, for classification, it is a fully connected layer that utilizes the output from the convolution process and predicts the class of the image based on the features from the previous stage. Okay, so this is basically an extension of what I said earlier. So, CNN typically comprises of three layers, which is convolutional layer, pooling layer, and fully connected layer. Okay, so basically convolutional layer is often the first layer, and its function is to extract the various features from the input image. So this is done by using convolutional method between the input image and a filter of a particular size. Okay, meanwhile for pooling layer, its function is to reduce the size of the convolved feature map to reduce the computational cost. And the next layer is a fully connected layer. This layer consists of the weights and biases along with the neurons, and it is used to connect the neurons between two different layers. These layers are usually placed before the output layer and form the last few layers of a CNN architecture. Okay, so other than these three layers, there are two more layers that are also available in the CNN model, which is dropout and activation functions. So dropout is typically used whenever a few neurons are dropped from the neural network during training process. Meanwhile, activation function is used to learn and approximate any kind of continuous and complex relationship between variables of the network. So basically, it decides which information of the model should it fire in the forward direction and which ones should be kept in the back. So the next model that I'm going to be talking about is BG16. So BG16 is a convolutional neural network model proposed by K. Simonian and A. Zitzerman from the University of Oxford. This model achieves 92.7% top 5 test accuracy in ImageNet, which is a dataset of over 14 million images belonging to 1,000 classes. So what this means is that BG16 is a very, very accurate and precise model. So from here we can see the BG16 architecture. As you can see here, there are like lots and lots of layers comprising it. So first of all, we get the input layers. Okay, so the input layer size is of a fixed size, which is a 224 by 234 RGB size. After that, it will go through the convolution process, which comprises of convolution plus value and max pooling, which is the same as I have said earlier, which is convolutional layer and pooling layer. After that, it will go through the fully connected plus value, which is also the same as what I said earlier, which is fully associated layers. And last but not least, it will go to the softmax. So BEJ44103, as I said earlier, is very accurate. However, it is also a very slow process. This is because, as you can see here, there are lots and lots of layers comprising it. So what this means is that usually people will use BEJ44103 in a smaller network module as compared to bigger ones, so that it will get accurate results and it will not take as much time. So the next model that we'll be talking about is the ResNet model. ResNet is short for residual network and is created as to solve the problems of missing gradient in deep neural networks. So ResNet have a couple of variants. Some examples are ResNet 50, ResNet 101, and ResNet 18. For our project, we'll be using the ResNet 50. So these are the building block of residual learning, which is, as I said earlier, this ResNet is built as to solve these problems. So how it solves this problem is basically by using a skip connections. So these skip connections will provide an alternative pathway so that the gradient does not get lost even if the size of the neural network is very big and deep. So in the best possible case scenarios is that the deeper or the bigger the size of the neural network, the more accurate the precision of the models. So that is all for the models that we have used in our project, which is CNN, BEJ44103, and ResNet, which in our case is ResNet 50. So thank you.
Assalamualaikum. My name is Nur Shakila binti Mazmin. My metric number is CE180047. So today I'm going to presenting about the result and discussion for this project. So in this project we have two tasks. So let me show you the result and the simulation for the task 1. So I'm going to show you the result and the simulation for the task 1, which is we are going to do a training and validation by using CNN model. So for the step 1, we need to connect the Google Cloud with the Google Drive, and then we just click run. Then it will connect it with the Google Drive. And then for the step 2, we feed a dataset directory. So we need to setting the data to feed the dataset directory. And then for the step 3, we are going to create train and validation data directory. So which is we are going to setting the file for the validation and train. So here is the file for the train, and here is the file for the validation. So here is the file for the test image that we want to, which is 3 images that we are going to test. So we will get the output, which is in train can file we have 156 image, and in file training pad we have 310 image. And then for the validation can folder we have 77 image, and for the folder validation pad we have 133 image. And then for the file test we have 3 image. And then for the next step, we need to import the important library. So we just need to run it to import the library. And then for the step 4, we are going to construct the CNN model. So here is the size for every convolution, so which is 32, 64, 128. So we just click run. So we will get this is the type of layer, and then here is the output shade result, and here is the parameter result for each layer. And then here is the total parameter that we got, and then the trainable parameter, and then the result for the non-trainable parameter is equal to 0. So let's proceed to the step 5, which is we are going to do a pre-process the input data. So let's click run. So in this step, we are going to generate the train folder, and also to generate the data for the test. So here the output we show we have 460 image belonging to two class, which is training for can and pet, and then found 220 image belonging to two class, which is the folder for the validation for can and pet. And then for the label batch shape, we assume we choose to set the batch size equal to 10. So for the step 6, we are going to start training the process. So we just click, and for this training process, we set the epoch equal to 10, and then for the step per epoch, we set it to the length train generator. So we just need to wait for a while until the result fully finish. So we need to wait until it finish to the epoch 10, and then we just wait. So after we finish, we can see the result here is show the training accuracy for epoch 1 until epoch 10. And then here is the validation accuracy for epoch 1 until epoch 10. So we can see the initial training accuracy is 0.6567, and then the highest is 1.00, and then for the initial validation accuracy is 0.6476, and the final epoch is 0.9810. And then we are going to the next step, which is plot the outcome. We will plot the result here into the graph. So as we can see, the output is here is the training accuracy, and here is for the validation accuracy, and here is the training loss, and here is the validation loss. So as we can see here, the first epoch is 0.6567. So the final epoch is final training accuracy is 1.00. We can see it from here. So next, we are going to test the image for the image 1, which is the pet bottle and can are side by side. The position is side by side. So we will get 100% for the can and 100% for the pet. And then we are going to test image for the image 2, which is pet bottle backward for 10 to around to 10 cm to 50 cm. So we are going to run. Then we will get 100% for can and 100% for pet. And then the final is test image 3, which is image 3. The can is backward to the bottle for around 10 to 15 cm. So the result is 100% for the can and 100% for the pad. So that's all for the task 1. So we will continue for the task 2. So for the result and simulation for the task 2, I'm going to show the BGG model first by using BGG model first. So we just click run for the step 1. So we need to get the password first. And then we need to copy the password. Just paste here and click enter. And then it's will connected to the Google Cloud will connected to the Google Drive. And then for the step 1 until step 3, it was a same step with the task 1. So we just run. So step 2 is for the feed dataset directory. Step 3, we create a train and validation data directory. And then for the step 3.1, we just import the library, just click run. And then for the step 4, we need to construct the VGG model, which is here we need to put the convolution base for the VGG 16 model. So we will get the output for the VGG model, VGG 16 model, and then the output show their dimensions and parameter sum, and each convolution layer output that can be seen in output shade. Here is the convolution layer. And then the final process, it will go through the flatten and descent process. So here is the result for the parameter and trainable and non-trainable. So for the step 5, which is a pre-process the input. Step 5 also same with the task 1. The coding also same. We just use a batch size equal to 10. And then we will get the output, which is it's found 466 image belonging to class, which is this is for the folder training. And then we found 210 image in belonging to two class in folder validation. And then here is the batch size that we use. And then for the step 6, we are start training the process for the VGG 16 model. So we are using same epoch, which is equal to 10. So we need to wait for a while until the epoch is finished running until to the epoch 10. So after the epoch 10 is done, we need to wait until it stop running. Then after that, we will continue to the step 7, which is plot the outcome. So we just need to run. So we will get the initial training accuracy is 0.8970, and then the final training accuracy is 1. So we can see here 1. So for the validation accuracy are 0.85, and then for the validation accuracy for the final epoch is 1. Yep, 1. So That's all for the task 2. So we will continue the demonstration to the task 2 by using ResNet model. So I will continue my presentation for the result and discussion and simulation for task 2 by using ResNet model. So for the step 1 until step 3 are similar step with the task 1 and task 2 VGG models. So step 1 we need to connect to the Google Drive. So we just run, and then after the Google Colab connected to the drive, we will go to the step 2, which is we need to feed the dataset directory. And then we proceed to the step 3, which is we need to create the train and validation data directory. And after that, the output will show the image in the train can is 156 image, and the length for the train pad is 310 image, and then the validation can is 77 image, and the validation pad is 133 image, and for the test image we have 3 image. And then for the next step is we need to import the library, which is the TensorFlow library and BGG16 and ResNet 50 library. And then for the step 4, we need to construct the ResNet model inside this coding. So we need to add on the coding for the convolution base, which is we need to put the ResNet coding here. And then we will get the result parameter for the ResNet models, and we will get the answer is too long, so we will get the layer type for the ResNet 50, and the output shade. Here is the convolution for the each layer, and then here is the parameter, and then here is the result for the connected to the convolution or input. And then we just need to scroll. So here is the result for the VGG for the ResNet model, and here is the result for the after the process of flatten and denses. So we will get the parameter for, here is the result for the parameter and train parameter and non-trainable parameter. And then we will proceed to the step 5, which is pre-process the input data. So we just need to run, and we are using the same batch size with the task 1 and also in task 2 VGG model. So we are using batch size 10. So we will found a 466 image belonging to two classes, which is training for the pet and can. And then we will found the 210 image belonging to two classes, which is validation for pet and can. So the label batch shape is 10, which is the batch size that we are used. And then for the step 6, we are going to start training the process. So we are using the epoch equal to 10. So we need to wait until it finish running into the epoch 10. So we are finished training the process for the by using the ResNet model. So here is the training accuracy, the result for training accuracy. Here is the result for the validation accuracy, and here is the training loss, and here is validation loss result. So we are proceed to the step 7, which is plot the outcome. So we will get this is the graph for the train and validation accuracy versus epoch. So based on the result, the initial epoch, which is at 1 or 0.6288, here 0.6288, and then the final train accuracy at the last epoch is 0.8 something, so as we can see 0.81. So for the validation accuracy, the initial validation is 0.61, 0.6333, and then for the last epoch for the validation accuracy is 0.6619. So as you can see here, 0.6619 here. So that's all for the result and simulation for the task 1 and task 2. So I will proceed my presentation with a comparison between task VGG 16 and ResNet. So we can see the different result between VGG models and ResNet model. So we can see the initial training accuracy for the VGG is higher than ResNet, and then the final training accuracy for the VGG is higher than ResNet, and then for the initial validation accuracy for VGG is higher than ResNet, and then for the final validation accuracy for the VGG is higher than ResNet. So we can conclude it, the VGG model is better than ResNet model. So next, we are going to compare the result between task 1 and task 2. So for the task 1, we are using CNN model. So for the task 2, we are use two model, which is VGG model and ResNet model. So we can see for the initial training accuracy for CNN is 73.18%, and for the VGG is 88.20%, 0.2%, and for the ResNet is 60.73%. And then we can see the best for the initial training accuracy is VGG, and then for the final training accuracy for the CNN is 100%, for the VGG is 100%, and for the ResNet is 78.76%. So the better one for the final training accuracy is for the CNN and VGG. So for the initial validation accuracy for the CNN is 86.19%, and for the VGG is 99.52%, and for the ResNet is 63.33%. So for the initial validation accuracy, the highest between three type of model is VGG. So VGG is the highest one. And then for the final validation accuracy for the CNN is 90.48%. And then for the VGG is 98.57%. And for the ResNet is 87.62%. So the highest for the final validation accuracy is at the VGG. So the best model between three model is VGG. So VGG model is better than CNN model and ResNet model. So in between CNN and ResNet, we can conclude CNN model is better than ResNet model. So that's all from me. Thank you.
Okay, so I will be talking about task 3. So for task 3, we are given an image and we need to investigate a suitable method that are able to identify and count the recycled material in the image. Okay, so for task 3, the method that we are going to be using is CNN method. More specifically, the fast RCNN method. Fast RCNN introduces a region proposal network RPN that shares full image convolutional features with the detection network, enabling nearly cost-free region proposals. The RPN component of this solution tells the unified network where to look for the object, making the process flow faster. For this task, we will use Keras with TensorFlow in the backend as implementation for the faster RCNN. The script for testing the network was modified so that it can process the image files and annotate each frame with appropriate data for detected objects, with probability as well as the summary of counted objects. Other than that, OpenCV is used heavily to process the images and already trained model while processing the frames. While object detection takes place during testing, we are creating the list of tuples with detected object class and number, which later gets reduced to count the number of occurrences for particular object class. Okay, so that's it for task 3.
Okay, last, I will present about the conclusion. So from task 1 and task 2, by using the same batch size and epoch value which is 10 and 10, the output plot outcome is different based on how construct the model by using different method. So student able to identify what difference between construct using model, CNN model, BGG model, and ResNet model. And at the same time, student able to think creatively on how to identify the three different picture, either it is can or bottle. This assignment also helps students understand more clearly about convolution neural network topics such as the input layer, hidden layer, and output layer for each model. Okay, that's all from our group. Thank you.